Hello and welcome to another segment of Further Mathematics. In this section, we'll be looking into the topic a cross product of vectors. But before that, let us review the previous lesson. Okay, welcome back. Now, in our previous lesson, we said something about the scalar multiplication of a vector. Now today I want us to talk about the cross product of a vector. Remember, I gave you a hint that while we're doing the scalar product, I said cross product is just equivalent to the determinant of such vector. And we stated clearly that, okay, let me say if we have A and B sine theta, we stated that it's equals to the absolute value of A cross B. That is, the cross here simplifies the cross product. Why, if it's a dot, we just have a dot product, and you know the dot product is a scalar product of it. That's a scalar product of it. Why the cross product happen to be the vector product between the two vectors. So if, for example, a vector is being given to you, and I said the essence of the cross product is to enable us identify the resultant direction of the vector. Since it's a vector product, it talks about both the magnitudes. Let me write the magnitude and direction. Talks about magnitude and direction of the vector. So that's the essence of having the cross product. So I would like us to apply our knowledge of determinant into solving the cross product of each given vectors. Now remember, let me give you a quick review of what and how we applied the determinant in our previous lesson. Now I stated clearly that we have numbers 2, 1, 3, 1, 0, 2 and 1, 1, 4, and you're told to look for the determinant. What you need to do here is to find the determinant. So what you need to do here is determinant will be equal to, you come to the measure axis, you can pick the column 1, or you can take the rows, that's row 1, 2, 3. But remember that there is a rule that is being assigned to it. The first member in the major in this major column has a positive sign. The next member here, element, has a negative, and the next one is plus. If we keep extending this, you have plus, minus, plus, minus. That is how it progresses. So we did something the previous time when we had a lesson on determinant. I said in order for you to get the determinant of a particular number, of a given number, all you need to do is come to the major diagonal and pick 2, which symbolizes this. Then just make a brief cancellation of the row, and its column you have 0, 2, 1, 4, which is 0, 2. You now have 0, 2, 1, 4. I took 2, so everything about this and this goes off. We now have 0, 2, 1, 4. Remember, it's a plus sign. The next one is a minus. You put minus to this row. What is here is 1. Then you take it. So if this is here, you take here and take here. You have 1, 2, 1, 4. 1, 2, 1, 4. That's for the second row. The third one now is plus 3. So we have plus 3 here. It goes off. You now have 1, 0, 1, 1. 1, 0, 1, 1. Remember, this is not what we are supposed to do right now. I'm just giving you a hint so that we use in solving our cross product when it comes to vector. So with this, we now have 2 in bracket. Remember, those in the major diagonal, subtract those in the minor. So we have 0 times 4 is 0, minus 1 times 2 is 2. The bracket is off. Minus 1. 1 times 4 is 4. Minus 1 times 2, which is still 2. We now have plus 3. 1 times 1 is 1, minus 1 times 0 is 0. So we now have 2 in bracket 0 minus 2 is minus 2, then minus 1 in bracket 4 minus 2 is 2, then plus 3 in bracket 1 minus 0 is 0. So 2 times minus 2 is minus 4, minus 1 times 2 is minus 2, 3 times 1 is 3, that's plus 3. So with this we have minus 2 minus 4 is minus 6 plus 3, which is equal to minus 3. So the determinant of the above matrix is equal to minus 3. So when we want to deal with a cross product, we also apply the same rule in dealing with it. Now let's go to that of a vector. Question, let's call it question 1. Let's say find the cross product. Find the cross product of the given vectors. And the vectors are A equals 4I minus 3j plus 2k, and B is equals I plus 2j minus 5k. Now with this, in getting the cross product, remember I said cross product is A cross B, which is now equal to, let's take the ij and the k term. We have the I, the j, and the k term. We want to transform it into a matrix so that it will help us to get in the determinant. So the first matrix have 4. What do we have here under I is 4. Here is minus 3, and here is 2. In the second matrix, we have 1, we have 2, and we have minus 5. We've succeeded in transforming it into a matrix. Now let's use the rule of the major axis. Remember, they have we have a plus, minus, and plus. So for I is plus I is equal to, if you take this and take the other, minus 3 minus 2, you now have minus 3 2 2 minus 5. You do that of the next one, and next one is j. We now have, remember it's minus j. You now have, what do we have here? It's 4 2 1 minus 5. 4 2 1 minus 5. And the next one here is k, which is what? Plus k. We have, if you shade this, the horizontal and the vertical, now have 4 minus 3 1 and 2. 4 minus 3 1 and 2. Now let's start with this. We have I in bracket minus 3 times minus 5 is 15. Then 2 times 2 is 4, so minus 4. That's for the first. We now have the next one is minus j. 4 times minus 5 is minus 20. Minus 2 times 1 is 2. You close the bracket, and we have plus k here. 4 times 2 is 8. Then 1 times minus 3. Remember, 8 minus 3, which is plus. So we now have I 5 minus 4 is 11 plus 22j plus k is 11k. So this is now 11I plus 22j plus 11k. So with this is the cross product of the given vector. But remember what happened when we're solving a dot product. We usually come up with answers that is not a vector. But the difference between a dot, that is to tell you that this is a cross product, because the answer should also be a vector signifying its magnitude, but not just the magnitude, and also its direction. I want us to solve one more example on this. Example 2. Let's look for the cross product cross product of P equals 2I minus 3J plus 4K, and Q being equals 5I minus 4J minus 3K. Okay, now remember P Q, the cross product becomes equal to, we state our I, our J, and our K term. Then let's start attaching it. This is 2, this minus 3, and this 4. This 5 minus 4 and minus 3. So the first one will now have I in bracket minus 3, 4, minus 4, and minus 3. I hope you know how we got this. This is a plus, a minus, and a plus. So you shade the major column of this Y. That's Y serves as a pivot. So anything related to it, Y, both horizontally and vertically, you shade it. You now have minus 3 and 4, minus 4, and minus 3. That's for this. Then we now have minus J, and in minus J we have, you shade here and you have 2, 4, 5, minus 3, 2, 4, 5, minus 3, and you do that of K plus K, you now have 2 minus 3, 5 minus 4, 2 minus 3, 5 minus 4. Now this is the value. Now with this, let's go into performing R. We have 1 in bracket, minus 3 times minus 3 is 9. Then minus, okay, it now turns into plus. 4 times 4 is 16, plus 16. We have our minus J in bracket, 2 times this is minus 6 minus 20. And this is plus K. Remember, 2 times minus 4 is minus 8. 5 minus 3 is 15, but it's now a plus, because 5 times minus 3 is minus, plus the minus is plus. So our value becomes 25I, then plus 26J plus 15 minus 8 is 7K. So with this happens to be the cross product of this. So if you have P, the cross product of P and Q is 25I plus 26J plus 7K. This is a cross product. I would like to say a very big thank you, and thanks again for joining us in this lesson. But if you want to actually refresh your memory on what we've just discussed, it is very, very important you take the test that appears on your screen. It will help you to check your level of assimilation when it comes to understanding the concept that has to do with vector cross product. Now, I also advise you do well to use the lesson notes on the platform for better information on the topic we've discussed. Thank you, and see you in our next lesson.